In the last couple of videos, I've shown you examples of returning defensive copies of a list and an array from getter methods. I also made a defensive copy of an array before I assigned it to my array field in a constructor. This slide demonstrates using a defensive copy as input. When you pass mutable types to an immutable object, a defensive copy should be made. The defensive copy should then be assigned to the instance field. This slide demonstrates using a defensive copy as output. When you retrieve data, you should first make a defensive copy and pass the defensive copy back to the calling code. Making a copy sounds easy enough, but unfortunately, that too isn't always perfectly straightforward. This slide is showing you two very different copies of an array. A shallow copy only makes a copy of the structure and not a copy of the elements in the structure. A deep copy makes a copy of both the structure and copies of each element in that structure. When you use copy methods on interfaces and helper classes, the copy that's made will probably be a shallow copy. A shallow copy of an array means a new array structure is created with the same number of indexed positions. Each indexed position is assigned the same value that was in the previous array at that same position. A copy of the referenced element isn't made. You can see in this diagram that both arrays have indexed references pointing to the same set of instances in memory. Deep copies usually have to be manually implemented if you need it. This slide demonstrates a deep copy of an array. Each array element has been cloned for the array copy. Deep copies may need to be applied to arrays and collections, as well as composite classes, to ensure immutability. It's not just arrays and collections you need to worry about. A class can be composed of other classes, meaning its fields are instances of classes. When you clone or copy this type of object, you may also need to copy or clone the class's more complex fields. This slide shows a shallow copy of an instance of a composite class, comparing it to a deep copy. Nesting of a composite class can be multi-leveled, as I show here with the JKL instance. JKL is a field on XYZ, which is a field on our object. The deep copy created new instances of ABC and XYZ, the fields on the object as well as a copy object. It didn't, however, make a deep copy of XYZ, which is why JKL is still referencing the same instance in the original XYZ. Hopefully you can see that when you start making deep copies, you may need to recursively copy fields which contain other fields. Let's get back to code and start looking at making copies and different ways to do this. I've created a new project called Copying Classes with the usual main class. First, I want to create a record called Person with two fields, name and DOB, for date of birth, both strings. I will just put this record in the main.java file. I'll create 5 person instances. I'll start with the first Joe and make his birth date January 1st, 1961. I'm going to copy that and paste it 4 times. The first time, I'll change Joe to Jim, both the variable name and the name passed to the construction of the record, and I'll change the date to February 2nd, 1962. The next one, I'll change to Jack, and the date March 3rd, 1963. After that, I want Jane, and birth date April 4th, 1964. Finally, Jill, birth date May 5th, 1965. Now I want to create an array of these persons. I will just use an array initializer with my 5 person instances above. I'll now create a copy, a shallow copy of my persons array. This should be familiar to you if you watched my last couple of videos. The person record has 2 fields, both strings. Here, I made a shallow copy. A deep copy of the record would be unnecessary since there's no way to mutate these person records. To confirm that the 2 arrays are referencing the same records, I'll set up a for loop. I'll loop through the 5 elements. I'll compare the element in the person array with the element in person's copy at the same indexed position. I'll use the equality operator, which checks whether the references are equal and not whether the values themselves are equal. If the references are equal, I'll print that out. If I run that code now, you can see that both arrays are referencing the same object for all 5 elements. Next, I'm going to change my person record. Like before, I'll include an additional field, kids, an array of person. I'll also generate a toString method, and I only want to include name and kids in that. Next, in the main method, I need to include kids for each of my person records. First, I'll include nulls for Joe, Jim, and Jane. Although the birth dates are wrong, I'll make Joe and Jim the children of both Jack and Jill. I'll run the code again to check equality. I get the result that all the references are still the same. I do have kids for Jack and Jill, the same kids, Joe and Jim. What this output means is that I still have a shallow copy of my array, the copy I made on line 29. Now I'll get Jill's kids. Jill is the last element in my copied array, so element 4, and I'll chain the kids accessor method to that. I'll change the second child for Jill from Jim to Jane. Running this code now. And the output still shows that all the references are the same, but what I want you to see is that Jill's second child is listed as Jane now. My code prints the reference from the original array, so these aren't the copies. Hopefully this example helps you see why shallow copies of arrays, when your array elements are mutable, could cause real problems. You know how to make this record immutable. But let's just say for some reason we don't want to make this record immutable. Instead, I want to make a deep copy of my array. How would I go about doing that? I could do it manually, which I'll do first. I'll comment out the arrays.copy statement on line 29. I'll create a new persons array calling it persons copy as before and initialize that to a new array with 5 elements. I'll loop 5 times. I'll set up a couple of local variables, so current will be the current array element, and kids will be current.kids. I'll create a new person record, passing it current's name, date of birth, and the kids variable. That gets assigned to my person's copy array element at the same index position. Okay, so I have a new record for every array element. Let's see what output we get now I have made those changes. What I want you to see is that I don't have any output at all. Remember, my code only prints records if the references in the arrays are the same. Since nothing is printed, this confirms I've created new instances for all my copied array's indexed elements. In other words, I've made a deep copy of the array. But what does my data look like? I'll print the last element of each array. First persons with index 4, then persons copy using index 4 again, running my code again. I can see my data is the same for both records. But I made a copy of the person record, so why did the change I made, changing Jill's kid to Jane, show up in both of these records? Well, even though my person records are different, Jill's kids weren't cloned when I made a copy of Jill. This means Jill and Jill's copy are referencing the same array of kids. This is an example of the problem I showed you on the slides, where nesting can be quite deep. I really made a shallow copy of Jill, but I need to make a deep one. I'll change the statement where I'm setting kids in my for loop to give me the result of a ternary operation. If the kids array is null, I'll return null, otherwise I'll return a copy of the kids array. Running that now. I now have code that doesn't have side effects for my original array of persons. The original wasn't changed, only the copy of Jill with its own copy of kids got changed. I have other options for creating deep copies. I could create a copy constructor, which I discussed in a previous video. I'll go to my person record and add a custom constructor, selecting no fields. I'll add an argument, a person type, and call it P. You'll notice that's giving me a compiler error. I'll talk about record constructors a little more coming up, but to make this work, I have to call what's called the canonical, or the generated constructor. I'll call this passing the method argument's name, and DOB, and I'll add a ternary operation, passing null if kids is null, otherwise doing a copy of the kids array on P. Now I can get back to the main method. I can remove the first statements in the loop where I'm copying the person data. Now I'll use the copy constructor I just created so I can call new person and pass the element on the person's array at the same index. If I run my code now, I get the same result as before. I can simplify my code even further, and instead of the for loop, I can use the arrays.setAll method. I'll comment out the for loop. I'll insert a statement above the comments there. Again, I get the same results. Finally, there's a clone method on arrays. I'll comment out the two statements I have here. Instead, I'll simply call clone on my person's array, running that code. You can see this clone method on the array only performs a shallow copy. Okay, so hopefully this cleared up any questions you might have about what shallow and deep copies really are. It's important to try to figure out when you need to create a deep copy and how deep when you're creating defensive copies. In the next video, I'll be discussing unmodifiable collections. See you in the next video.